Question 4. We're given this diagram here. We can see the triangle ABC. M is the midpoint of this side, and N is the midpoint of this side. In part A, we want to express ON in terms of A and C. So O to N. Now, either you can see what the answer is straight away because this is the midpoint, or we could do some working. To go from A to C, I would go backwards along A and forwards along C, so that would be C take away A. So A to N, since N is the midpoint, would be a half of C minus A. If I want to go O to N, I could go OA plus AN, and that would be A plus a half of C, take away a half of A, which is a half A plus a half C, or half A plus C, which is the answer you may have seen straight away because N is the midpoint of AC. We also wanted OM in terms of B and C, and by the same argument, that's going to be a half of B plus C. In part B, we want to show that the modulus of A is equal to the modulus of B is equal to the modulus of C, even though it may not look like it in the diagram. The first thing to note here is that ON is perpendicular to AC. So that means that a half A plus C dotted with AC, which was C minus A, has to be 0. So we can ignore the half. Expanding out, A dot C plus C dot C, take away A dot A, take away C dot A, is equal to 0. A dot C and C dot A are the same, so that's C squared minus A squared is equal to 0, and therefore C squared is equal to A squared. And then similarly, using these sides, we would get that C squared is equal to B squared. It follows that A squared is equal to B squared is equal to C squared, and therefore mod A is equal to mod B is equal to mod C. Now in part C, we're told that P is the midpoint of this side, and we want to show that this is a right angle. So AB would be backwards along A, forwards along B, which is B minus A. And OP, from what we've learnt before, must be a half of A plus B. So if we dot them, a half A plus B dotted with B minus A, we're going to get a half of A dot B plus B dot B minus A dot A minus A dot B. These will cancel, so we have a half of B squared minus A squared, and we know from before that that's got to be 0.